Welcome back to Science Modernzers. In today's video, we are going to have a physics lesson on data analysis, which is a part of experimental physics. So let's get started. A brief introduction to experimental physics. What is experimental physics? Experimental physics is that branch of physics which is concerned with the observation of physical phenomenon and experiments. So basically, what is an experiment? An experiment is a well-organized activity with the aim of discovering, verifying or testing physical ideas or phenomenon. These activities are carried out in a room called a laboratory. So when we talk of testing phenomena, they are simply natural phenomena. For example, to determine the value of the acceleration due to gravity on the Earth's surface, which is 9.8 meters per second squared. So in order to do this, we can use several methods. We have the method of the simple pendulum, the spring method. So basically, in order for us to conduct this experiment, we have to go into a closed room called a laboratory. So in the lab, in fact, we have types of experiments mostly involved in physics. And the first one, we have the station. So what is a station? This is a short experimental investigation based on a theme or a fact. So basically, here the experimenter is not given a procedure, but you are just given a set of materials in order for you to verify an existing phenomenon. So for example, you are provided with the following to determine the density of the material used to produce the ball. We have the first is spring balance. You are provided with a spring balance disposable cups. We have a spherical ball, and then we have a vernier caliper. So how then can we use this to determine the density of this material which the ball was made from? So all we know is we have a spring balance, and we know a spring balance can permit us to measure the mass of this ball. So one thing we have to know is, before trying to investigate something, it's always good to know the relationship or what quantities are supposed to be measured. For example, in density, to calculate the density of a material, it is simply the amount of mass contained in that material per unit volume. So density is mass on volume. So this sphere has a given mass which can be measured using the spring balance. So if the mass of this can be measured, we note it as a certain M. And using the vernier caliper is an instrument which is basically used in measuring the diameter of spherical objects and even wires. But in most cases, we also use the micrometer screw gauge for wires. So this can be able to measure the external diameter of this sphere, and you can measure it at several points and take an average value of the diameter. And with the diameter, we can calculate the volume of the sphere, which is given by 4/3 pi radius cube, knowing that the diameter is 2 times the radius. So that is how we can actually determine the density of this material. So we clearly see that no procedure was given to us, but all we have is a set of experiments with an instructions, and we are provided with the following to determine the density. So that is basically what the station is all about. So the next is the mainstream experiment. Now here the experimenter is actually given a list of instructions to follow in order to verify a given phenomenon. So this is an experiment in which candidates are given instructions and are expected to follow up these instructions and obtain data, analyze that data by plotting a graph and drawing conclusions about the observations on the graph. So yeah, procedures are always given, and procedures are not required from the students since they're already given. So all we need to do is to simply follow the steps given unto us in order to derive what is being asked in the question. So the next is we are going to see the steps involved in reporting an experiment. Now, when reporting an experiment, there is a particular procedure we should follow. The first is the title or aim of the experiment. This is usually the main task in an experiment, and it has some given characteristics. What are those characteristics? It should not be ambiguous. It should be short as possible, bringing out the main theme of the experiment. For example, an experiment to determine or to verify the value of the acceleration due to gravity on the Earth's surface. That's a very brief title. In general, an experiment to verify Hooke's law. So you are verifying Hooke's law. It is very straight to the point. So when you are writing in lowercase letter, if you write a title, your title in lowercase letters, it should be underlined. But if you write it in capital letters, then don't underline it. The next which we see is the requirement or the apparatus. So this is simply a list of equipment needed for the experiment. As we saw earlier, they gave us a list of equipment. That is, they gave us the spring balance, disposable cups, the spherical ball, and the vernier caliper. So that's an example of requirements that are given to you in order for you to verify an existing phenomenon. So the next which we see is the setup or diagram. So a setup is actually the pictorial representation of the experiment, and it should have the following characteristics in general. So one thing we know is the diagram should be large enough for easy verification, and for another person trying to read the experiment, let him be able to understand your setup, because the setup is transmitting what you have actually done. Yes, like the setup, what you have actually done, like what is actually before you. So another person should be able to reproduce while looking at your diagram. So it should not contain it should contain a few parameters as possible. When we talk a few parameters as possible, it means don't over congest the setup. Is not good. So make it simple and make sure that the information you want to pass should be well transmitted. The next is the procedure or the method. So this is actually the chronological account of what an experimenter did. So what you do, you actually give in order, what you actually did in order for you to achieve the results which you are actually giving out in that experiment. So that is actually the procedure, and your procedure should always be brief and be very chronological. So don't tell someone in the beginning you measure the mass of the substance and you measure it and you note it m. The next step you tell me, for example, tell the examiner that you measure the radius of the sphere and you measure it r, and after you start by telling him again you measure the mass. No. So basically it should be very brief. If you have just 2 steps in your procedure and that it explains everything you did, then it's okay. Now the next is the observation and the results. This is actually one of the most important parts in an experiment. So the representation of the results or observation depends on the experiment, the method of representation of such database in general, and it is always based on scientific notation, and it has instructions by the examiner. So you tell the person that this is what you have observed while doing this, and you report your results. Now once you report your results, what's the next thing you do? You collect data and you analyze the data, and this is the main focus of the video today: data analysis. So when we collect the data, we have to analyze the data. Now one thing you have to know is, while collecting data in a laboratory after conducting an experiment, avoid writing them on pencils because they can wipe out and you won't be able to deduce the exact value that was written there. And if you assume a value at the end, your result might be wrong. Next, don't collect data on rough sheets of papers. It is not good because you might misplace the paper, and at the end you will be forced to create some values which might give you wrong conclusions, yes, and wrong observations. So always present your data in a manual or in a clean book, so that the data you have collected in the lab should be conserved and let it be kept well. So we can actually analyze data in several ways, and one of the most used and most frequent ways in physics is the graphical method. So data collection and data analysis. The following should be noted when reporting data. The first, avoid reporting or collecting data on rough sheet of paper. As I said, avoid recording data with pencil. It is very important. Now, there are different means of analyzing the data, and the first is we are going to see the graphing, and this is what we are really going to emphasize on the graphing part of the data which you have collected in the laboratory. What is a graph? A graph is actually one of the most frequent used mathematical tools in physics, which is the representation of your points on a given graph paper. So a graph is a diagram showing the relation between variables, typically of two variables, each measured along one of a pair of axes at right angles. So this is an axis. This is actually the Cartesian plane which you observe here. We have the y-axis and we have the z-axis. Now on basics, these axes are actually drawn on what we call a graph paper, and a graph paper has the shape, and this is actually the format of a graph paper. So a graph paper in general, in most cases a graph paper is made of 22 boxes vertically and 18 boxes horizontally, where one of these square boxes represents 1 centimeter. So in general, the dimensions of a graph paper in the form length by width is 22 by 18. So that is generally the representation of a graph paper. So let's see the features of a graph. A graph normally has two axes which are perpendicular to each other as seen on the diagram. The vertical axis is called the ordinate axis and the horizontal axis is called the abscissor axis. So that's, in other words, the y-axis is called the ordinate axis and the horizontal axis is called the abscissor axis. The graph should always have a title which is obtained from the level axis. For example, a graph of force against separation. If you are plotting a graph of force against separation. On the case of a simple pendulum, you can say a graph of length against t squared to verify the value of that relation due to gravity. A graph must have a sensible scale, and this is actually one of the problems which many students face today. The big problem in data analysis is choosing an appropriate scale. So let's see how to do this manually. When choosing a scale, you should consider the following. The scale should be such that the plotted points in bracket graph occupies at least 3/4 of your graph paper. So if the graph paper has 22 boxes vertically and 18 boxes horizontally, so it means you need to occupy at least 3/4. 3/4 is 75% of the graph paper. And if you take 75 on 22, will give you roughly is 16.5. That's at least 17 of those boxes should be occupied vertically, and horizontally you simply have to take 75% of 18, which is going to give you at least 13.5. That's an approximately 14 boxes. So that is the meaning of the scale should be in such a way that it occupies at least 3/4 of the graph paper. If not, you won't be able to deduce or to verify some phenomena perfectly, because the more accurate your scale is, the more accurate your results will be. The next is it should be easy to plot and understood by someone else. So if I take your graph and what you have plotted, I should be able to know that I should be able to read and understand what you are trying to transmit through the graph. It should not be complicated, and scales should always follow a regular pattern, that is the pattern of an arithmetic progression with a constant common difference. And also note that a scale must not necessarily begin from 0. You can begin from any point and indicate on your graph paper that this is not the origin. Okay, so it should be easy to process. So basically, let's see an example of a scale on the graph paper. So this is a graph paper in general, and let's see the possible scale which you can have here. So we have on the vertical axis, you observe values of 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So you clearly see that there is a constant difference between 0 and 2, and that constant difference between 2 and 4 is still maintained, and the difference can simply be calculated by taking 4 minus 2, and you see that it is 2. And likewise, this other side, we can also have 2 minus 0, which still gives 2. So for all values on this scale, you clearly see that there is a constant difference, and that constant difference is 2. So you have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that is the characteristic of a good scale. And always try not to use the same scale on both axis. So if you use this on the vertical axis, try to use something else on the horizontal axis. And on the horizontal axis, you see we have 0, 0 0.1, 0 0.2, and there is a constant difference of 0 0.1 between the values. 0 0.2 minus 0 0.1 is 0 0.1, 0 0.1 minus 0 is 0 0.1, 0 0.8 minus 0 0.7 is 0 0.1. So those are the characteristics that a graph should always have, and each time you are plotting a scale, make sure it follows all these properties. So in general, when calculating the scale, most of us don't know how to calculate the scale, but this is actually an estimated manner of calculating the scale, which is not sometimes the best, because there is no absolute best scale. No, it doesn't exist. So the more you plot graphs, the more you do experiments, the more you plot graphs, the more you get used to scales, and the more you get used to scales, the more easy you will find it to deduce or to derive a scale for given values. So for if you are just beginning data analysis and you have difficulties in finding scales, we can simply use these relations on the screen. As you can see, the range is equal to the highest value minus the lowest value. That is for the given data which has been given to you. We are going to see an example, and the ordinate scale, that's the y-axis. If we assume that the graph paper you are using is having 22 boxes vertically and 18 boxes horizontally, then the ordinate scale is going to be the ordinate range divided by 22, and the abscissa scale will be the abscissa range divided by 18. Now if your graph paper is having more than 22 boxes or less than 22 boxes, then you simply take the ordinate range divided by the number of boxes which you observe on the graph paper, and you take the abscissa range divided by the number of boxes which you observe on the graph paper on the x-axis. So let's take an example. Here we have a table of values which shows actually the resistance of a given conductor, how it varies with temperature. So the resistance is measured in ohm. You should always note this when doing your table. When drawing your table, it carries the name of the quantity you are measuring / the unit, and against temperature in degrees Celsius. So we have at a resistance of 22.5, we have the temperature at 0 degrees, we have a resistance of 22.5, and at 10 degrees you clearly see that the resistance is increasing to 23. So the ordinate range now will be the ordinate range, or the ordinate scale in general, is simply going to be the ordinate range divided by 22 if we are using a graph paper which contains 22 boxes, and it is simply obtained by taking the biggest value minus the smallest value. So you see that the biggest value here is 31.6 minus 22.5. That's actually the range divided by the number of boxes, and in this case we shall use 22, and you see that this ratio gives us 0.414. And you clearly see that in order for us to use this scale, we can use it to be 0.5. So we can take one box to be 0.5. Now if you take 0.5, it's 0.5 times 22. You are going to see if all your values will be able to enter that the scale in general. So 0.5 times 22 in general is going to give you 11 values. So will 11 values be able to enter? Yes. If you start at a 0.5 for one box, you will be able to cover all that range. Likewise, the abscissa range, you do the same. For the abscissa range, you simply take 100 minus, this is the biggest value, 100 minus 0, the smallest value, divided by 18, which gives us an approximate of 5.56, which someone can decide to use 5 or 6. But basically, these particular values are very easy to plot, because we see that they are simply multiples of 10s. So we can just deduce a simple scale there to be 0, 10, 20, 30, 40, 50, 60, 70, 80, or you can still take it in terms of 5s. So as I said, this method of calculating the scales is not actually the best, but it gives you at least a clue on how you can consider one box to be. And in most cases, it is the more you plot graphs which you tend to deduce that I can use this type of scale for this graph. So what then can we see? One thing we know, as I earlier said, is there is no absolute best scale. So no scale is the best. So use your scale and don't compare that much with others. Just get used to and make sure the scale which you have chosen follows the properties which are listed above. So this now brings us to the end of this video, the end of the part 1 video, and now thank you very much for watching and thank you for your keen attention. Stay tuned for part 2, for more videos will be uploaded in order to enhance your understanding in physics. In the next video, we are going to see the family of curves in bracket lines. We are going to see straight line graphs and curves in general, where we are going to treat good examples to enhance our understanding. Please do not forget to like, share, comment and subscribe. Thank you so much for watching. Stay blessed and see you the next time. Science Modernizers, modernize the educational world.